Hello students, welcome to the YouTube channel RD Academy, an educational channel that is completely dedicated to the learning of pure science. Okay, so we will pick up where I left off in the previous video. So before that, I want to tell you that I will be also uploading a detailed handwritten notes for all the chapters once I complete the chapter entirely. For example, as soon as I complete the electric charges and fields chapter, I will upload an entirely handwritten notes which consist of important points and derivations from this particular chapter in my WhatsApp channel with the same name. Okay, so if you are not a participant of the WhatsApp channel, kindly join the WhatsApp channel using the link in the description. Thank you. So without further delay, we will go to the next section in your NCERT textbook. Okay, so the section name, section 1.2 in your textbook goes by the name of electric charges. Okay, so previously I have told you that this entire chapter we will be dealing about the electric charges, but what is that extra condition? The charge has to be at rest. Okay, so then there will be various properties like electric field originating around it, that and all we will learn it as we go through the chapter. Now electric charge. Now before studying what electric charge is, you need to look at how the concept of charge was developed. Okay, now take silk or wool cloth. Okay, and you have one glass rod. What happened is that when you rub this glass rod with the silk, this glass rod temporarily takes up some charges, and this silk cloth will gain some other charges. Okay, so let us not give which is positive or negative now. I will tell that later. Similarly, you take a cat's fur, okay, and rub it with the another plastic rod. In this scenario also, what happens? The cat's fur gains one type of charges and the plastic rod gains another type of charges. So what the scientists observed was that when they brought two types of these glass rods which are rubbed with silk or wool cloth, they saw that these two glass rods repelled each other. Similarly, when you bring near two plastic rods rubbed with the cat's fur, they also repelled each other. Repelled in the sense they move away from each other. Okay, but when you bring a glass rod with the plastic rod, they both found to be attracted. That is, they started to move towards each other. So scientists, after conducting various experiments, they concluded that once you rub the silk with the glass rod, this silk gains the electrons, hence it becomes negatively charged, whereas this glass rod loses electrons and hence it becomes plastic charge. So now can you guess what happens when you bring two such glass rods near to each other? See, both of these glass rods are rubbed with silk cloth. So what happens? Both of them will lose the electrons and both of them will become positively charged. So when you bring the like charges, they repel each other, that is, they move away from each other. In a similar explanation here also, when you rub the cat's fur with the plastic rod, this cat's fur loses electrons, hence it becomes positively charged, whereas this plastic rod gains that extra electrons lost by this cat's fur, hence it becomes negatively charged. So now can you guess what happens when you bring two such plastic rods rubbed with cat's fur near to each other? Since both of them have same charges, they also will repel each other. So when you bring a glass rod rubbed with silk cloth, which induces a positive charge in it, and a plastic rod which is rubbed with cat's fur, which induces negative charge in it, they both will attract. That is, since they are having opposite kind of charges, they will attract. When they have like kind of charges, they will repel. So this was the conclusion that scientists came towards the end. What is the first point? The first point is that like charges always repel. Okay, so if you bring a positive charge with the positive charge, they will always repel, that is, they move away from each other. The second point is that unlike charges attract. when you bring a positively charged glass rod with negatively charged plastic rod, they both will attract each other. So this was the conclusion. Okay, and here one important point I would like to mention is that the charges, okay, the charges, we normally use positive and negative charges, but do you know who gave this name that one should be positive and one should be negative? It was coined by an American scientist, namely Benjamin Franklin. Okay, he was the first person to call one type of charge as positive and another type of charges as negative. Right, so there's from that time we are using this particular notation. Right, so next, if you have understood this one, now we need to see how can we identify whether a object is charged or not. Okay, so there is one device that is known as gold leaf electroscope. Okay, gold leaf electroscope. So this is a device used to detect the charges on any body. Okay, so this construction and working is not important, but nevertheless I will teach you that because it is very interesting on how this device is constructed. Fine, so now assume you have a metal knob. A metal knob is any knob like your door handle. Okay, so this is a conductor, it conducts electricity. So this metal knob is attached to a metal rod. Okay, and this metal rod at the bottom end is attached to two thin gold leaves. Now what do you mean by gold leaves? Gold leaves are nothing but gold plates. Okay, normally you get that aluminum foil, no? So same type of material, but it is made up of gold, and this entire apparatus is enclosed in a cubical box. Okay, so in order to create a vacuum like condition, now I will bringing a charged body A towards this gold leaf electroscope. So how will I identify whether it is charged or not charged? So as soon as this body, whether it is charged or uncharged, I don't know, when this body touches this metal, now what happens? If at all it is charged, it doesn't matter which kind of charge it has. If at all it is charged, what happens? Assume it has positive charge. Since metal is a conductor of electricity, the positive charges in this charged body will flow to the metal knob. Okay, the metal knob is in turn connected to the metal rod, which is also again a conductor of electricity. So these charges will start to travel, and finally they will come to this gold leaves. So what happens now? Since the gold leaves are very nearer to each other, if this body had any charge, when both of the gold leaves acquire same charges, we already know that like charges should repel each other. So if at all this charged body had any charges, then this gold leaf will deflect. Initially they will be like this, both attached to each other, but as soon as a body with the charge touches this metal knob, these charges will travel and deflect this gold leaves. Okay, and this amount of deflection theta indicates the amount of charge present in the charged body. So if this gold leaves comes like this 180 degree, what can you say? They are deflected more, hence this charged body has more number of charge. That was the conclusion. Okay, so this is the working of gold leaf electroscope. So if at all they ask what is gold leaf electroscope, you can just write that it is a instrument used to detect the charges present in the body. Okay, so I hope there is no doubt. And another one important point here is that take a copper wire. Okay, I'm sure you have used it in your labs. Fine, so copper is a conductor of electricity. Then why don't we get the electric shock as soon as you touch the copper wire with the bare hands? Does that, since you are not getting electric shock, does that imply that the charge this copper wire has no charge? That is a wrong assumption. Okay, see, any conductor in its natural state has both positive charges and negative charges. Okay, you cannot say that there are no charges in the conductor, but what happens is that in its natural charges, the amount of positive charges present in it is equal to the amount of negative charges. So as a whole, what happens? That effect is nullified or cancelled out. So in spite of having the charges, this copper wire behaves like a uncharged body. Okay, but that doesn't imply it does not have any charge. It has charge, but it has equal amount of positive and negative charges. Okay, so in MCQs they will ask this, okay, whether a conductor has no charges or not. So you should always remember materials which are electrically neutral contain charges, but the charges are exactly balanced. Okay, now you need to learn one notation in this electrostatics. The notation is that whenever one body, suppose you have a body A, assume this body A lost some electrons moved away from it. Okay, whenever a body loses electron, we assign positive charge to it. Okay, similarly, this lost electron, if it is accepted by another body, then it becomes negatively charged. So the next point you need to remember is that if a body accepts electron, then we assign a negative charge. Okay, so using this idea, can you tell what happened here in our discussion of silk and glass rod? So we assign this positive and negative charge, right? So here it implies that this glass rod lost its electrons to the silk or wool cloth with which it is rubbed. Okay, so hence it becomes negatively charged, whereas the glass rod becomes positively charged. Similarly here also, the cat fur, when it is rubbed with the plastic rod, the charges in the cat's fur got transferred to the plastic rod. That's why this cat's fur is positively charged, whereas the plastic rod is negatively charged. Okay, so in this particular section, the important thing is the charges. Okay, always remember glass rod has positive charge when it is rubbed with silk or wool. Similarly, a plastic rod will have negative charge when it is rubbed with cat's fur. Okay, like charges will repel, unlike charges will attract. And gold leaf electroscope, it's just for the interesting how the device works. Okay, that is not much important, but this notation is important. Okay, this notation is entirely used in your part 1 of the textbook. Whenever you see something as positively charged assigned, whenever you see any object assigned a positive charge, you need to know that it has lost its electrons. Similarly, whenever you come across a body which has negative charge, you need to know that it has accepted the electrons. Okay, so this completes the 1.2 section of your NCERT textbook, that is your electric charge. Okay, so if you think someone will benefit from this explanation, kindly share this video with them. We will see in the next section. Thank you.